Okay, so first I'll go over this question. There's a request. Okay, so first number 40. What is the total number of atoms in 0.139 moles of that particular compound? Okay, the 0.139 moles of P026. P139 moles of P or H26. Was it plus 2 or plus 3?
Very plus.
Okay, it doesn't. So it doesn't affect the result. Okay. So this is the question. So first, we're going to identify how many atoms are in this molecule. So how many atoms in this molecule? What is the total number of atoms in this molecule? How many? Okay, so this is one oxygen, two hydrogen. So there are three atoms within the parentheses. So 3 times 6 is 18. And then one ion, 18 plus 1 is 19. So there are 19 atoms in this molecule. Is that clear? Okay. So now we can convert moles into atoms. 0.139 moles of that as okay. So we can convert moles into Avogadro number or formula unit. So we can convert into molecule. The 1 moles of this compound can be or H2 has Avogadro number times molecules. 10 to the power 23 molecules of that compound. Okay. So in one molecule, there are 19 atoms in total. Okay, so we didn't calculate the specific atom, so it's total atoms. It's going to be 0.139 times Avogadro number times 90 because each has 19 atoms. Does it make sense? So we did several examples. We're going from like how many oxygen atoms, how many hydrogen atoms. So you can do it separately. Like you can calculate all the hydrogen atoms, all the oxygen atoms, all the iron atoms, and then add everything. The same thing.
So where does the 3 positive come in?
3 positive doesn't do anything in this calculation. So that's the formula of the compound. So it's an iron. That molecule is an iron. So 3 plus means it has plus 3 electrons. So it doesn't affect the number of atoms.
That's just like the charge.
Yeah, it's just charge on the molecule. Yeah. So nothing to do with the 3 plus charge. It's just a charge like sodium ion. So it's just charge. You can do the calculation and the answer is going to be what is the answer? I don't know. I think it's COE. Maybe not. Yeah. Okay, so calculation is here. Oh, not good. Okay. Okay, that makes sense.
Is it 8?
Right, 139 times. Yes, 1.59 times 10 to the power 24. That's the answer. See. Any other difficult question? Okay, so if you don't have any difficult question, let's go to the study guide. The study guide has like 20 questions, maybe 25. I don't remember the 20. one, again, starting from moles or grams. So grams to atoms of carbon. So in the previous calculation, we started from moles. So in this calculation, we are going to start from grams. So grams to moles, we are going to use the molar mass. So you can see as a help, you can convert grams into moles. The rest is going to be same like previous question. So we can convert 24 grams of sucrose into atoms of carbon. Okay, this is the first question. 24 grams of sucrose, the 12, 22, or 11, divided by the molar mass, so it's 342 point. What is it? Grams of C12, H22, or 11 into 1 moles of the same compound. So we use the given molar mass to convert given grams into moles. So then we can convert moles of this compound into moles of carbon. So each molecule has 12 carbon. So 1 moles of that compound has 1 moles of C12, H22, or 11 has 12 moles of carbon. Because subscript number in the formula is 12. And last one is going to be carbon moles to atoms of carbon. 1 moles of carbon, Avogadro number. Okay, so if you need only moles, you can stop at this point. So if you're going for atoms, that's the atoms of carbon. So 3 conversion factors. And answer is, I have been done. 5.47 times 10 to the power 23 atoms of carbon. Definitely there will be one question like this. So I'm going to pick a different molecule and different mass. They're going to divide by the molar mass of the given compound and then use the formula, convert moles to moles of the element. And then last one is the Avogadro number. Any question? Next one is identifying types of chemical reactions. There will be 3 questions to recognize combination reactions, decomposition reactions, and combustion reactions. Okay, there's something wrong with this. So it's going to be multiple choice. You're not going to write, but I gave you several reactions, and then we can identify types of this reaction. So what is the type of the first reaction? Is it combination, decomposition, or combustion? Okay. What is the type of the combination? So if it is a combination reaction, A plus B produce C. So that's the combination, combined form a single product. And opposite of that is the decomposition. So this is combination. Yes. Decomposition is a single product splits into simpler substances, B and C. It's the opposite of that. The third one is the combustion reaction. We have a fuel and one of the reactant is oxygen. Okay, so we have that, and products are carbon dioxide and water. So then it's going to be combustion. So we have all 3 in the combustion reaction. So hydrocarbon plus oxygen produce carbon dioxide and water. The type of the reaction is combustion. Okay. Next one. Okay, so now I have explained all 3 types of reactions. Is it combination, decomposition, or combustion? Yes, so we have 2 reactants, 1 product. It's going to combine. It's combination. Combination. Okay, next one, calcium carbonate, break down into calcium oxide and carbon dioxide. Decomposition. Next one, lead carbonate, break down into lead oxide and carbon dioxide and after lead two oxide and carbon dioxide. Decomposition. Both reactions have the same format. It's decomposition. Next one, magnesium and oxygen produce magnesium oxide. Combination. So next one, okay, it's the same reaction. So 4 and 6 is same decomposition. Next one, combustion reaction. So in a combustion reaction, we need all three. Otherwise, it's not going to be combustion like. So this is going to be combustion. And last one, decomposition. Yes. Okay. 7.5 in the exam. So you will get 3 questions. Next one. How many grams of calcium chloride are needed to make 50 grams of calcium sulfate? And you have the reaction. Okay. So how many grams of calcium chloride? Grams of calcium chloride is required. Okay. Make 50 grams of calcium sulfate. So this is the calcium sulfate. And we have 50 grams of calcium sulfate. So we're going to do mass to mass calculation. So starting from mass of a reactant and then convert into mass of a different product. So it's a mass to mass calculation. And that flow chart is on front page. It's a mass to mass. Okay, so something else. Okay, so these are the flow charts. So we're going from mass of substance A into mass of substance B. This is how we are going to set up a calculation. So divide by the molar mass of the given substance and then use this stoichiometric coefficient and then multiplied by the molar mass of the required compound. Okay. This is question number 3. Chemical reaction is calcium chloride plus Na2SO4 produce calcium sulfate plus NaCl. Yes, so that's the balanced reaction. We need to sort it so right. So always I will give you the balanced reaction. So we're going to start from 50 grams of calcium sulfate. Okay. So first we are going to convert 50 grams of calcium sulfate in moles. Grams of calcium sulfate, moles of calcium sulfate. 1 and molar mass is given in the question. So let's go to the question again. So molar mass of calcium sulfate is given 136.14. So you don't need to calculate that. It's given in the question. So we're going to use that value. 136.14. Answer down. So next one, mole to mole factor from the balanced reaction. So given is calcium sulfate. Okay, so number is 1. 1 moles of calcium sulfate produce. We're going for calcium chloride. 1 moles of calcium chloride. If I give you a different reaction with different coefficients, use those coefficients. So it's not always 1 to 1. So this can be changed. So it comes from the reactions. This cancels out. So now we have moles of calcium chloride. So we can convert moles of calcium chloride into grams. 1 moles of calcium chloride equal how many grams of calcium chloride? So molar mass of calcium chloride is given. So you have excess details. So you don't need to use all those numbers. So you have molar masses of all those 4 compounds. Use the required ones. So this is 110.98. So this is given in the question. Okay. And answer is 40.76 grams of calcium chloride. And into the math, it's going to be 40.76. Any question? Okay, so if you don't have any question, let's move to the next one. The next one, you're going to do 3 mass to mass calculation because it's limited Texas and percent yield calculation. Okay, so this is question number 4. So you will get a reaction similar to this one. And in the question, it says, in a particular experiment, the reaction of 15 grams of iron with 16 grams of oxygen. 15 grams of iron and 16 grams of oxygen produced 19.3 grams of Fe2O3. So amount of Fe2O3 produced from the experiment is 19.3. So this is the actual yield. It is asking the percent yield of the reaction. So in order to determine the percent yield of the reaction, first we must understand which one is the limiting reaction. Okay. So since I'm going to break down this into 3 questions, so in the first, I will ask you to calculate the limiting reactant and excess or theoretical yield of the product Fe2O3. So we are going to do 2 mass to mass calculations starting from grams of iron, then moles of iron into moles of Fe2O3, and then into grams of Fe2O3. That's our first calculation. Starting from grams of iron to more grams of Fe2O3. So 15 grams of iron. This is an element. So we have the molar mass in the periodic table. So we are going to divide by the molar mass of iron, 15.85 grams of iron, and 1 moles of iron. Okay, so next one, moles of iron into moles of Fe2O3. We use the coefficients 4 to 2. So 4 moles of iron produce 2 moles of Fe2O3. So that's what we learned on Wednesday afternoon, mass to mass. We use the balance coefficient from the balance reaction. And last one, molar mass will be given in the question. So it is not given here, I guess. But I will give you the molar mass of all the compounds. So Fe2O3 molar mass is 159.7 grams of Fe2O3. 1 mole is equal to that mass. Okay. So the answer is going to be 21.4 grams. When you do this calculation, answer is 21.4 grams of Fe2O3. So which means once we consume all 15 grams of iron, it will produce 21.4 grams of Fe2O3. So we are going to do the second calculation, starting from grams of oxygen, moles of oxygen into moles of Fe2O3, and then into grams of Fe2O3. So 16 grams of oxygen started from 16 grams oxygen, and 2 times oxygen is molar mass of oxygen. 32 grams of oxygen is equal to 1 moles of oxygen. The next one, oxygen to Fe2O3. So we are going to use the coefficient from the reaction, oxygen to Fe2O3, 3 to 2. 3 moles of oxygen produce 2 moles of Fe2O3. And last conversion factor does not change because we are going for the same product. So we're going to multiply it by the molar mass of Fe2O3. So the answer is equal to 53.23 grams of Fe2O3. So now we have calculated the same product from each reactor. Okay. So this tells us the theoretical yield, which is going to be the lowest. Because after it produced 21.4 grams of Fe2O3, we will consume all 15 grams of iron. So when it is asking theoretical yield of the reaction, this is the number. So definitely this will be less than the actual yield of the experiment. So actual yield of the experiment is given 19.3. So using those two values, we can calculate percent yield of the reaction. Okay. The percent yield of the reaction is actual yield divided by theoretical yield times 100. Actual yield will be given the question. Theoretical yield is 21.4. So the grams times 100. This is going to be the percent yield of the reaction, and this is 90%. And third question is going to be how many grams of excess chemical left. Okay. So it is not asking in the study guide, but you will get in the exam how many grams of excess chemical left at the end of the reaction. So we are going to do another mass to mass calculation based on our limiting reactant. So our limiting reactant is 15 grams of iron. Okay. So we are going to do the third mass to mass calculation from grams of iron into moles of iron. Moles of iron and moles of iron into moles of oxygen and moles of oxygen into grams of oxygen. That is the required amount of oxygen. So we convert 15 grams into moles, moles into moles of oxygen, 4 to 3, and then we multiply it by the molar mass of oxygen. The required amount of oxygen consume 10 grams of iron. Why we are using iron? Because iron is the limiting reactant. So we can convert 15 grams of iron into moles grams of oxygen. So divide by the molar mass of iron. 55.85 grams of iron. 1 moles of iron. Then iron to oxygen. So that's the direction we are going. Okay. So iron is 4 and oxygen is 3. So 4 iron produce 3 oxygen. 4 moles of iron produce 3 moles of oxygen. And last one is moles of oxygen to grams of oxygen. 1 moles of oxygen, 32 grams of oxygen. Okay, so I don't have this answer because it is not in the study guide. But 15 times 3 times 32 divided by 505. 6.44. You can use that 6 point. This is the required amount of oxygen. Consume all 15 grams of iron. The given was 16 grams. So 16 grams of oxygen given. Subtract required. And that is going to be the leftover or excess chemical. Amount of excess. So this is the given amount of oxygen and we subtract the required amount of oxygen. Okay. Do you have any question? Okay, so probably that might be the most difficult question. So first we have to find the required amount of oxygen and then subtract it from the given. Okay, so then there will be 2-3 questions to balance chemical reactions. So we talk about those at the beginning of the chapter 3. So in order to balance the chemical reaction, we count number of atoms, not molecules, not ions, not anything else. So simply we count number of atoms. Okay, so this is a combustion reaction. Carbon, hydrogen, oxygen. How many carbons is this on the reactant side? How many carbons? How many? 5. How many hydrogens?
Well,
12. How many oxygen? 2. Product side, how many carbons? 1. How many hydrogens? 2. How many oxygen? 3. There are 2 oxygen in carbon dioxide and there is 1 oxygen in water. The total is 3. So now you have to balance this reaction. You can start from carbon or hydrogen. Definitely you will get 1 combustion reactions like this. Okay, so there will be some additional reaction. 1 is going to be a combustion reaction. So 5 to 1, we need 5 carbon dioxide. Okay. So that's the number required to get 5 carbons to product side. So when you add 5 in front of carbon dioxide, it will change oxygen. The new number of oxygen is going to be 5 times 2 is 10. Now we have 10 in carbon dioxide plus 1 in water. So 10 plus 1 is 11. Make sure to update the other atoms. The next one is hydrogen, 12 versus 2. So we need 12 on this side. What is the number in front of water? How do we get 12 hydrogen to product side? 6 water. 6 times 2 is 12 hydrogen. So 6 times 1 is 6. So this one change into 6. 10 plus 6 is 16. So now we need 16 oxygen in front in reactant side. What is the number in front of oxygen? 8. We don't need to change this. So those are the coefficients. 1856. That's how we balance chemical reaction by counting atoms. Whether it's polyatomic or normal reactions like this, it is balanced based on number of atoms. Okay, so this is another reaction. So I think I did this example in the lecture. Yeah, so you can look at this question. So I think I explained this. I can do it again. CH4 or 2. Okay, C2H4. C2H4 oxygen plus oxygen produce carbon dioxide and water. Okay. The number of carbon to number of hydrogen 4, number of oxygen 1 plus 2 is 3. Product side carbon 1, hydrogen 2, and oxygen 3. So let's balance carbon 2 versus 1. But update number of carbon into 2. So change it into 2. New number of oxygen 2 times 2 is 4. 4 plus 1 is 5. Hydrogen 4 versus 2. So we have to change this one into 2. 2 times 2 is 4. New number of oxygen 4 plus 2 is 6. So now we need 6 oxygen on this side. So we already have 1 here. And we have to get the remaining. So 6 minus 1 is 5. Okay. So we need 5 more oxygen atoms on this side. So there's no way to get 5 oxygen atoms using this. So which means we have to multiply all those numbers by 2. Okay. So we balance this. We're going to update new numbers by multiplying into 2. All these numbers are going to be double. Okay. So now we can count new number of oxygen again. So 2 plus 2 is 4. And product side, 2 times 4 is 8. 4 times 1 is 4. 8 plus 4 is 12. So we double that number. So now we need 12 on this side. So we already have 2 here. Okay. 12 minus 2 is 8. So we can get 10 from this part. So 5 times 2 is 10. So 10 plus 2 is 12. Okay. It was given because it's a study guide. It was given in the study guide because it's a study guide, so you can work hard on this question. Okay. So next one, formula weight. There will be a couple of questions to calculate the formula weight. Those are easy questions. Don't miss that. So in order to calculate a formula weight or molecular weight, we simply use the formula times atomic weight of each element. So in this formula, just 1 calcium, 1 carbon, 3 oxygen. Okay. So 1 times 12.41. It's from periodic table. This is calcium. Calcium is 40.48, I guess. This is carbon, 1 times 12.41 and 3 times 16. So don't forget this. Okay? So that's the subscript for each atom. So you can add all these numbers, and I think answer is 100.9. If it is formula weight, unit is atomic mass unit. Formula weight, unit is atomic mass unit. If it is the molar mass, same value, unit is grams per mole. That is the difference between formula weight and molar mass. So molar mass is the mass of 1 mole of particles. So this is the mass of 1 molecule. Okay. That's why we have 2 different units. And also you should be able to do the same thing with polyatomic ions like aluminum sulfate. So we did this in the class Al2SO4. So you should multiply this subscript by the number outside of the parenthesis. So in this molecule, there is 2 aluminum. There are 2 aluminums. And how many sulfur? Sulfur is 3. And how many oxygens? 12. Okay, so 3 times 4, 12, and this is 1. 1 times 3 is 3. So most of this time some students will forget that part. So you have to multiply it by the number outside of the parenthesis to get the number of atoms. Okay. At least 2, maybe more questions to calculate molar masses. And there will be 2 questions like number 9, calculate the percent composition. Okay, so percent composition of an element in a compound. So this is the example. Percent composition of carbon in C2H4O. The required equation is on front page.
So
Yeah,
we'll have this.
Yes, you will have that on the front page, not in colored. I don't have a color printout. And if you prefer to have a colored copy, you can bring the colored copy, but don't write anything on that page. Okay. So you have to show me before the exam. So don't write anything if it is a colored copy. Yeah, otherwise it's going to be black and white. Okay, so this is the equation. Percent composition of an element is going to be number of atoms of the element times atomic weight of the element divided by formula weight of the compound. Okay, so in this question, you may need to calculate the formula weight of the compound. Otherwise, you will not be able to do this question. Percent composition of carbon in this is going to be according to the equation number of elements, subscript number 2, atomic weight of the element. Use your periodic table. 12.01 atomic mass unit and calculate the formula weight of this compound. 2 times carbon, 4 times hydrogen, and 1 times oxygen. It's 44.46. 44.46 atomic mass unit times 100. Calculation. And answer is going to be the percent composition of carbon.
So I was like,
54.5%. Is carbon. Okay, so there will be two questions from this. Okay, so next one is grams per moles, simple calculation. One molecules actually, not simple. Let's go to the next question, number 10. So how many water molecules are in the 45 grams of water? Okay, so you are going to use this conversion, grams to formula unit. Grams into moles, moles into formula unit using the Avogadro number. You're going from grams to formula unit. Okay, we have only 11 minutes left. Given 45 grams of water needed, molecules of water. Molecules of water come from the moles of water. And moles of water comes from the molar mass. So I will give you the molar mass. 18.02 grams of water is equal to 1 mole. And this is the definition of 1 mole. General equation is on front page. 1 mole is equal to Avogadro number times molecules of water. Okay. So now we can set up our calculation. 45 grams divide by molar mass, and that's 1 moles of water. And last one is moles of water into molecules of water. 1 moles of water, Avogadro number times. Answer is 1.5 times 10 to the power 24 molecules of water. Okay. That is the answer. And the next one, empirical formula from percent composition. So you have percentages for a compound. So percentages are 42.11 carbon, 6.42 hydrogen, 51.41 oxygen. So now we can use these numbers to determine the empirical formula. So we are going to assume these percentages as grams. The carbon is 42.1. Hydrogen is 6.48. And oxygen is 51.41. So then we are going to divide by the atomic weight of each element. So when you divide the mass by atomic weight, your answer is moles. So 12.41, 1.41, 16. So your answer is going to be moles of each element. These values are 3.506, 6.416, and 3.21. So now we are going to identify the lowest. 3.213 is the lowest. So we divide all by the lowest. This is equal to 1. This is equal to 2. And this is like 1.9. Sorry, 1.09. So 1.09 is close enough to 1. So we can round off this into 1. This is equal to 2. This is equal to 1. So now we have our empirical formula. C, number of carbon is 1. Hydrogen, number of hydrogen is 2. 4 is 1. So C1, H2, 4. Okay, so there will be one question like this. The next one, there will be another question from this equation. Again, you can use this flow chart to do that. Okay, so mass percent divide by grams of each element. Okay, so that's the flow chart we used in that calculation. And then use the molar mass, so that's moles of that. And divide by the lowest moles of each. And then you are going to get the empirical formula. So that's the flow chart we used for that calculation. The next question comes from other equation. This one. Mole number multiple is equal to molar mass divided by mass of empirical formula. Okay. The next question is from that. The empirical formula for vitamin C is this. Experimental data indicate that the molecular mass of vitamin C is 180. What is the molecular formula? So when the empirical formula and molar mass of the compound is given, you are going to use this formula. Mole number multiple is equal to molar mass divided by empirical formula. This is the empirical formula. C3 H4O3. Molar mass is 180 grams per mole. Okay. So mole number multiple is equal to molar mass divided by empirical formula mass. Okay. So we don't have the formula mass of the empirical formula. It's going to be 3 times carbon, 4 times hydrogen, and 3 times oxygen, 3 times 12.41, 4 times 1.41, 3 times 60 is equal to 36, 3, 4, 4, 48. 88.07. Okay, so that's the empirical formula mass. So we have our molar mass given in the question 180 divided by 88. Is it 88 or 89? 88, I guess. Grams per mole, that cancels out. So this is 2 point a number. So we are going to round off to the nearest integer, these 2. So that's the whole number multiple we need to determine the molecular formula. So we are going to multiply the empirical formula by that whole number, and then we will have our molecular formula. So 2 times 3 is 6, 6 carbon, 2 times 4 is 8 hydrogen, and 2 times 3 is 6 oxygen. That is the molecular formula of the given compound. Okay. Any question? And I have to speed up a little bit because we have only a few minutes left. These are some multiple choice questions. Again, the molar mass of potassium is, okay, so there will be one question like this. It is from your periodic table. Go to your periodic table and find the atomic mass. So I think it's 39.10. Okay, so it's a straightforward question. Next. 1 mole of a particle of any substance contain how many particles? So that is the definition of 1 mole. Avogadro number times. So Avogadro number type 1 mole of particles of any substance contain this number. Avogadro number. 10 to the power positive. Pay attention to the value. It's positive exponent. And again, next one, same question from a different direction. Avogadro's number is the number of particles in 1 mole. Okay, so particles in 1 mole of a substance. Avogadro number is the particles in 1 mole of a substance. So let's go to the next question. Balancing a chemical reaction, okay, with a polyatomic ion. So you should be able to recognize that polyatomic ion. 1 polyatomic ion, 3 polyatomic ions. Okay. So sulfate in reactant side is 1, product side sulfate is 2. You don't split sulfur and oxygen. So if you split it, it will be difficult. Okay. So it's 3. So we can balance sulfate. So we need 3 on this. So once we balance sulfate, total number of hydrogen is 6. So we need 3 in front of this. So I think it is asking the number in front of hydrogen. Okay. So the other one should be 2 aluminum. Now it's a balanced reaction. So answer is 3. Okay, so we need a similar example to this. So you can balance that one. 3 more questions, 2 minutes. True, false. The molar mass of chlorine gas is 35.45. Is it true or false? Molar mass of chlorine gas, 35.45. True or false? Okay, so that's why I picked this question. So what is chlorine gas? Chlorine is a diatomic molecule. So chlorine is this chlorine atom. Chlorine gas is a diatomic molecule. We talk about 7 diatomic molecules. Then it is false because it's 2 times the atomic weight of chlorine. So diatomic molecules, I mentioned that several times. It's going to be atomic weight of the element times 2. So
Okay,
it's
but
false.
you could say, you could fix it by just multiplying it times 2.
Yes.
Okay,
So it's asking the chlorine gas molar mass is this false because it's the mass of chlorine atom.
all right.
I mean 1 moles of chlorine atom. So next one, the following is a decomposition reaction, true or false? Okay, so break down into simple substances. Next one, that reaction is correctly balanced, yes or no? So you simply need to count number of atoms. The 2 times 2 is 4 carbon atoms. So we have 4 carbon atoms. It is balanced. You're going to count number of atoms. 2 times 2, 4 hydrogen. 2 times 2, 4 hydrogen. Hydrogen is balanced. So 5 times 2 is 10 oxygen. So there are 8 oxygen and 2 oxygen here. 8 plus 2 is 10. That is the balance reaction. Okay. And if you have any question, you can bring those questions to the lecture on Monday. Okay, then I can answer those questions. If not, I will start chapter 4. Okay, hold on. So your presentation. Would you like to have your presentation on the same day?